PLC இருக்கிற அக்கௌண்ட் நாங்கள் பிரச்சனை லிங்க் ஸ்டார்ட் ஆகிடுச்சு லைவ். லிங்க் தாரன்னு இருக்கா, காப்பி பண்ணி எனக்கு அனுப்புறியா? இதில் யார்கிட்ட வாட்ஸ்அப் இருக்கு? මං ලින්ක් එකක් දෙන්න ඒකට යනවා.
ලින්ක් එක ඔයාලට එවන්න ඕනේ.
ඔව් මට එවන්න ඕනේ.
මෙතන WhatsApp එකේ
normal YouTube open වෙන්නේ.
මෙච්චර වෙලා ලයිව් එක ගියා. කේබල් එක මුගේ වයිෆයි එක මට කේබල් එක ඊළඟ කේබල් එකකට ආයෙ ලොග් වෙන්න බෑ. ලැබ් දෙකක් කනෙක්ට් කරලා තියෙනවා කියලා.
මේ WhatsApp එක.
ඔව් නේ ඔක තමයි. ඒකේ පාස්වර්ඩ් දැක්කද? පාස්වර්ඩ්
මගේ නම් කොහොමද ෂෙයාර් කරන්නේ? DH දාන්න.
නැද්ද?
මේක නම්බර් එක.
දවාන්සි දවාන් හරන් මේ මොකද්ද?
මේ වෙන account එකක් ගන්න ඕනේ.
මම හිතුවා ඒක ගැලවුණාම. හරි. එතන ගැලවුණා.
ලයිව් පටන් ගන්න තියෙනවා.
හරි මොකක්ද තිබෙන්නේ අපේ මට සිරි වෙනවා තව පොඩ්ඩක්. නෑ අපි ට්‍රයි කරමු. දැන් මම යව අල්ලන්නත් බෑ. ලයිව් එක වෙන්නේ මෙතනද? බලන්න ලයිව් එක මාරු වෙනවද කියලා.
මාරු වෙනවද කියන්නේ? හරි මේ ලින්ක් එක ඕන බෑ. මේ ලින්ක් එක කොහොමද ගන්න ලින්ක් එක? වීඩියෝ ෂෙයාර් කරන්න නේද?
Make a channel. Adala. Studio. Make a channel. Adala. Studio. Public up. Private technical. Public up. Private technical. Table unta input karo.
body lab के क्या अभी lab क्या body lab के अपना पैन ये होता है ये होता है कैम्मिक ऐदा गति है ना कैम्मिक ऐदा ही नहीं कैम्मिक ऐदा गति है ना कैम्मिक ऐदा ही नहीं मानता ऐदा ही नहीं ऐदा गति है ऐदा ही नहीं मानता ऐदा ही नहीं
The Artificial Intelligence, Data Science and Emerging Technologies session of the 7th International Research Conference 2025, organized by the Tripoli Campus, Eastern University, Sri Lanka. This session brings together innovative minds, researchers and practitioners who have contributed to the advancement of technology and shaping the future of intelligence systems. Who have contributed to the advancement of technology and shaping the future of intelligence systems. Who have contributed to the insights into cutting-edge technologies will undoubtedly inspire us. Sir, we are truly honored to have you, sir. It's my great honor to introduce our session chair, Mr. S. Sodiswaran, sir, Senior Lecturer, Grade 1 in Computer Science, Department of Computing, Faculty of Science, Eastern University in Sri Lanka. His primary research interest includes medical image processing, machine learning, computer vision, deep learning, and pattern recognition. With his extensive academic and research expertise, Mr. Sodiswaran sir has been contributing significantly to advancing the procedures of intelligent systems and data-driven technologies. We are privileged to have him as the session chair of the session and data-driven technologies. We are privileged to have him as the session chair for valuable insights through this process. It's also my pleasure to introduce our session co-chair, Mr. S. Tachanamurthy sir, Senior Lecturer in Computer Science at Tripoli Campus, Eastern University, Sri Lanka. Sir's dedicated academic with extensive experience in teaching and research in the field of computer science. His commitment computing studies at the university level. We are honored to have you, sir, to serve as the session co-chair for this session. And also a special welcome to all our presenters and co-authors who have worked diligently to produce innovative and thought-provoking professional educator and researcher with over 3 decades of distinguished experience in the global maritime industry. Sir born in 1976 and is began his maritime career in 1995 after completing his pre-sea training at TS Jamaica. He holds a Master of Maritime license in 2005 and MBA in Shipping and Logistics Management in 2011 and an unlimited BP license from Nautical Institute of Lifting. He is currently pursuing his PhD at the Indian Maritime University. With more than 30 years of experience, his expertise spans vessel maneuvering, offshore. With more than 30 years of experience, career includes 16 years at sea and 7 years in offshore operations and 7 years in maritime education. In the offshore sector, Captain Vishwanathan sir has commanded vessels supporting oceanographic research, ROV operations, heavy lift construction, platform supply, and deep sea missions across the Indian and Southern Ocean. His leadership has extended to projects in Malaysia, India, Africa, and Peninsula. Since 2010, he has made remarkable contribution to maritime education, serving in key academic and administrative positions such as Principal, Dean, and Director, Integrated Maritime and Fisheries Institutions. Currently, he serves as an Associate Professor at the Indian Maritime University, engaging in teaching, research. Currently, he serves as an Associate Professor at the Indian Maritime University, engaging in teaching, research. Currently, his vast experience and insight at the Indian Maritime University, his vast experience and insight.
Good afternoon, everyone. Session Chair, Mr. Satish Maran. Session Co-Chair, Mr. S. Dashnamurthy. Session Coordinator, Dr. Dinamshi. Session IT in charge, Ms. Ramya. And participants and other friends, a warm good afternoon to everyone. Thank you very much for wonderful introduction. Interesting for any of the maritime professional coming and giving a guest lecture in a place like where the artificial intelligence, data science, and emerging technologies are the papers of us. It's my privilege. I'm very happy to be here because countries like India, Sri Lanka, any third world countries, they are contributing very happy. The emerging technologies in the maritime field is very less, but it is a very good opportunity to bring my experience and what is happening on board and what are the evaluations taken place since last 30 years. If I throw some light on that, at least the contribution for the next generation is going to be a good advantage for them. Let me just discuss about what is next generation, what is for over 4,000 years. One of the second oldest profession in the world is something related to the maritime. They call it as fire. So, for trading from one place to other place, you need your position. Because in the middle of the ocean, if you are there, it's very difficult for you to reach your destination unless you don't know. You have the good information about where you are. I'll tell you during Sangam Internations about 2,500 how they were trading, how they were coming to India and Mediterranean Sea had very good trading. How they were doing it now? During 200 to 250 ships used to come from Red Sea, reaching India, and during the other monsoon season, that is Northeast monsoon season, they used to go back. That was happening. As a over period of time, during even that time also, they were always relying on the as a over period of time, during even that time also, they were always reach back to Red Sea. It was possible those days. But as that time goes, during 1,000 years back, when Solar Kingdom, when they conquered Java, like how they went there? If you go from Nagapattinam, they came to east of Sri Lanka, then they made a parallel navigation, parallel to the equator. So they exactly know this particular star on a particular month, particular date is going to rise to its, they exactly know, and they say that we will reach Java on so date, they were able to reach. That is the kind of knowledge they have. But over a period of development has taken place, very recently. When I joined in 1995, the positioning was GPS was just before that. There is something system called satellite. Again, that was also satellite based. The satellite based position is just before that. Again, that was also satellite based. So we have to just have the approximate position is so and we should travel. But when the GPS came, yes, it was a very good system. It was made by USA. One particular frequency was available for the shipping community. So we were using it. The error was about 50 meters, and one particular frequency was available for the shipping community. So we were using it. The error was about 50 meters, and so there were some errors. After that, Russia made its own system for positioning by using the satellite, and all the countries like China has and the European Union has the overall all over the world, they can give a position. But India has a regional system. When we are having this system, like the latest vessels, it is not only used for the vessel but also for the offshore vessels. When we are having this system, today the GPS or GNSS, they have accuracy of in centimeters. But today we are going to have a discussion on various the objective of my subject is like this is a question system in the marine space and to find the alternative to global navigation. Why do we need that alternative? Because navigation system is depending upon the satellite based system, and it is limited to 4 countries, basically China, European Union, Russia, and USA. Tomorrow something goes wrong internationally, they want to shut down. It is a very serious problem. So you must have alternative. So that is why, I will be just discussing what is available in the industry, what we need in the positioning system in future. That will help you just frame so that you can put together what we need in the positioning See the satellite system, how they work. There are satellites around the earth, particularly for this positioning system. Take the example of GPS. It has got 24 satellites in the medium earth orbits, 6 orbits, and the other system like Coronas, Galileo, they have 3 orbits, total about 24 satellites. Generally, all of them are medium earth orbits, and except Beidou is having geosynchronous and geostationary orbits of these satellites, so that they can just give a position of the ships or receivers in a latitude and longitude form. Mainly, they are using them for the surveying ships, offshore activities, we want to lay a pipeline and everything. Everywhere, even if geographical information system also need GPS position, it doesn't use everything. But every satellite's position is known. It is sending that position information to the receiver. Receiver receives the information and calculates the position and calculate the distance of the satellite from the atomic clock which is there in the satellite, quartz clock which is there in the receiver. It calculates how much is the traveling time, then it determines what is the distance. If you receive 4 satellites distances, then you can put a fix. We call it as a fix because you can fix your position. So that is the technique they follow. for the satellites. The accuracy, okay, if you want to calculate the distance of the satellite, what are the errors? Errors are there because when it is following through the atmospheric errors are there, sometimes multiple errors are there, and it is also liable for somebody want to hack the system. It is possible for hacking also. So there are so much other drawbacks are there for this. The accuracy is generally initially 50 meters, now it is up to 5 meters. 5 meters is quite good, but to enhance that accuracy, they brought another system called EGNOS, Pagan, MSOS, WAS. These are all like ground-based augmentation system or satellite-based augmentation system. How it works? I have a station here. My exact position is known in millimeter. I see the satellite information. I recalculate that. If the error is about, let us say, about 5 meters, then I calculate the error for each satellite. Then I transmit that to chips around it. Then the chips receive this information, applies that error to the information it receives from the satellites. Then you will get the error in centimeters. It's very, very accurate. But the transmission, sometimes it is through land, because if it is through VHF frequency, it can reach up to 40 nautical miles. Maybe some area it will go to 100 nautical miles. But if you are in the ocean, it can be transmitted to satellites. So you get a fairly good accurate position through GNSS, Global Navigation Satellite System, and we also call it the DGN, Differential Global Navigation Satellite System, that is SBOS and CBOS, that is the same thing. Very good. Without that, today the maritime industry will not run, because where 90% of the trade is taking place through maritime. Your position is very important. Even today they talk about sustainability. When they talk about sustainability, consuming of 1 ton of fuel, it releases a lot of fuel. For example, like we are going from Singapore to Gulf of or Aden or maybe like Suez, and if you are not having the proper positioning, because of that, even if you are consuming 1 hour of extra fuel for a container vessel, big container vessel today, consuming about 200 tons of fuel per day. Just imagine 1 hour how much they consume, how much they release, and how much the financial release. So positioning is very important. This is a very good job for that calculation. Weather predictions, weather calculations, and all. Very nice. But what are the limitations? There are only 4 countries are controlling this, and it is a single medium. That is another big thing. Tomorrow, all the satellites get affected by a solar storm. What is the alternative for the ship to follow? There is nothing. There are no alternative on the ships. When the India's satellite system fails. So this is the limitations. With this limitation, now we have to see what are the other systems are available in the industry and where they stand. Another important system which is available is enhanced Lorentz system positioning. This is a hyperbolic navigation system where there will be a master station, there will be 3 secondary stations. They will be transmitting the signal together at 90 to 100, 110 kilohertz range. It's actually it is a low frequency band. Power transmitters. This was already there before the GPS thing, because the hyperbolic system, the charts also prepared to the lines. You can exactly calculate and you can plot your position. But again, this range is about 1000 nautical miles. You cannot go cover the middle of the Atlantic or middle of the Pacific. There is a lot of limitations. But they have brought it back as a E Lorentz. And if there is any error, that also can be transmitted through Lorentz data channel. It has got a provisions for that. This is about 100 meters. With the corrections, it can be reduced to 10 meters. Again, 10 meters is not good for offshore, but for ship it is okay. But what is the other problem for this? If you look at this picture, it is limited to regional. US, okay, they are happy with that. Europe, they are happy with that. What about African countries? What about Asian countries? Are they willing for this? No. So global coverage is very much limited. So it may take longer time for it to get established in the maritime industry. Another possible solution for the positioning is the pulsar navigation. I think everybody in the space. There are so many pulsars have been identified. They transmit X-rays and radio signals. Normally, this system is used for tracking the satellites in the space. Very well established system. Can you use it for doing the navigation in the our region like sea or in the air? We cannot use the X-rays because X-rays are very difficult to detect because they are very big. But radio signals is of course we can receive. When we are using radio signals of the pulsar for our positioning, the error may be about 100 nautical miles. It's sorry, at 100 meters. But do we have receivers for that? You need a very powerful receiver. If you look at the ship, which is about 200 meters long, that receiver itself will be having a 200 meter size antenna or a part of antenna. It's very difficult. Technology has to come, to produce it, to make that antenna to receive a pulsar. But that is a very long. Moreover, because of its and the radio pulsar are costly detection system. It has to be evolved for that as an alternative to GNSS. What else is there? Inertial navigation system. This is a very good alternative because, okay, ships are using GPS or GNSS for information. What about submarine? Submarine uses this system. Inertial navigation system. It has got an accelerometer and gyroscope to calculate how far it is moving and how fast it is scanning. So these two accelerometers, when you put from your starting point till where you reach, you can calculate the velocity, displacement and heading. It's a very good system. It is independent. Nobody can hack because it is on board your vessel, except whenever you have power failure, then it may get affected. But that can be taken care by backup powers. Resistance to jamming, spoofing, nothing is there, but there is error. A small error in the accelerometer or gyroscope, over a period of time, you may have a good number of errors. Again, it's a relative system. It doesn't give a position in latitude. It only gives a travel distance and which direction. So you need some backup, like global navigation satellite system for initial position, or maybe every 1 hour, it will get an update from the GNSS. Combination of GNSS and inertial navigation system works well as of now. Moreover, for the gyroscope and accelerometers, there are so many other new technology equipments are coming, laser, fiber optical, quantum gyroscopes. That will reduce the error. Okay, it's a recent development. The last one is quite interesting. This extent is the equipment, we were using it for measuring the height of the object, which is there in the sky. Basis that we were calculating here before the GPS came. Even when I joined the ST, we used to do calculations based on this system. Now we are converting that system into this system. Automatically. This is a way the electro-optical sensor which track a particular star or sun, moon, planet. You can just program it in such a way that it continuously tracks, calculates the altitude, recalculates our position from the star. Whatever they were doing earlier, exactly you are going to convert that into electronic way with the emerging technologies. If you are using this, it is going to be, when combined with INS, that is Inertial Navigation System, it is going to be the best alternative for your GNSS in case that fails. But again, there is a problem. If the sky is with cloud, how we are going to do it? That is a drawback, but still, with the inertial navigation system, it is capable of doing whenever there is a sky is covered, it's overcast and we are not getting any stars. That time, inertial navigation will take care. Once the sky is available for ease extent, it will take the position and it will just be together they can work. Here also, it is completely independent. Doesn't depend upon anybody else. Nobody can do any jamming or spoofing. Nothing is possible. Nothing can interfere with that. It is your own. So position accuracy is around 100 meters as of now, but there are two companies are making it, the SatNav and another CPOT, that is a German company. They are into that electronic optical sensor for tracking the stars or sun even during the daytime. If that becomes successful, definitely this is going to be one of the best alternative for the navigation positioning system. So what from this study, as we are all into artificial intelligence and data science and emerging technologies, you must go for this. Some technological equipment so that find a GNS, alternative to GNS. The best according to me is this one. Navigation system and along with your ease that will be the best possible. What is the future after 10 years or 15 years? We are going to run the ship without people. Even now already started. Cochin has constructed one vessel for Norwegians where nobody is there on board. They are taking the vessel from port A to port B by tracking from shore. If you want that kind of, we call it the MAS, a maritime autonomous surface ships. So those ships need a very robust GNSS. It's one of the backbone of navigation of those vessels. So without alternative, they cannot navigate a vessel in these conditions, relying only on the GNSS. So it is one of the gap which is there in the maritime industry. With this conference, the technicians or researchers, they can take this subject into their future studies. Okay, so thank you very much. All the best for the future chemistry.
Thank you, sir. I kindly call our chair, Mr. Sotishwaran sir, and co-chair, Dakshinamurthy sir, to present the solemn Thank you, sir. Now we shall move to our first paper presentation. I am pleased to invite Dr. paper and data science application. Associate Professor from the Department of Computer today I am going to discuss about myself and my co-author Dr. Both are presenting this. My paper title is 5G and its influence on data science applications. First, we have to know what's 5G. Nowadays, we all hear about this 5G. It is a revolutionary concept in the communications, telecommunications, and also ICT communication systems. Primarily, it was developed in South Korea. It was implemented in South Korea, but no one is importance. No one is celebrating and the first inventor. All the three organizations have produced this 5G concept at the same time. Primarily it was identified 2013 and also in commercial it was launched in the year 2019. So, what's the introduction? 5G represents the transformative leap in the wireless communication. Mainly, it is the ultra fast connectivity and also reduced latency. Latency means retrieval system of the information from the other servers or other data providers, and also suppose millions of IoT devices. IoT devices is Internet of Things devices. Nowadays, we all having in our house all smart devices. This 5G technology helps us to act as to connect as a central medium of all the smart devices in our organization, wherever it is. Next. These are the diagrams. First one objective, and because of the short time we are taking only 5 minutes. We both of us having only 10 minutes. So, what is my objective? My objective of this analyze how 5G advances in data science applications across industries. Data science
grown in all over the world for our fast-growing human beings and industries as well as in every field. For example, what is the application? These kinds of 5G generation things and that we have to focus. So here I am going to explain you about what are the things we can, in which area we can produce these kinds of 5G and what are the uses and advantages of there. So I am going to explain that. So here the smart factories also nowadays everything. What is meant by smart means without human power, if you are going to emerge with the industries and we are going to collaborate with everyone, we will need we need more humans. But nowadays it has been taken over by the machines, right? Through the sensors. So IoT, cloud, and deep learning, networking, everything are one-on-one interconnected and playing the raster role. So networking is LAN connection, MAN connection, for speed, especially for speed, this 5G is very much important one. But one of the things, the drawback in this 5G means it cannot move into the thing easily. So they are nowadays they are working on it. In future, the 5G only the 5G on the living concept. So we had taken this 5G presentation. So I will explain what are the areas industrial automation for predictive maintenance of real-time data storage. Nowadays, if we are storing in cloud, we will use, for example, Asco's cloud. Asco's cloud is used for a fee. Otherwise, we have to use pay as you go. We all know that by paying only we can buy the storage for the virtual memory and we can store everything and we can use it. But by using this 5G, the speed will be enhanced. The data will not be, for example, yesterday also we came here from India, but we have stuck with the network. Network is a last problem for us. We don't know how to connect to our family and how to blend with them. So it is a major problem for this. For 3 days I am thinking about my child only. So we can overcome that kind of current problems. I am telling about the current scenario. So this is the predictive maintenance and for the industrial automation for car and everything. SAP code hereafter there is no human for riding the ship. So similarly nowadays the electronic vehicle has been came. So that is one of the example for industrial automation. Then telemedication. You all know that India and Rajni, everyone is seeing that film, right? In that for monitoring the baby, they have used the technology. Similarly, in future also we can use that kind of technology where we can help of sensors. So we need a fast and monitoring concepts, monitoring sensor devices. On that time, the 5G is very much useful in the artificial intelligence area. For example, cloud connected with medical devices means it can store every data because sensor processes to monitor each and every content for each and every fraction of second. So the storage area is very it should be a huge. So we need virtual storage area. So to avoid the big data concept, that is a huge explanation for big data concept because we are storing in YouTube and everything we are storing inside the cloud. We are not deleting anything. So that is a major concept in deep learning. So that is one of the things. Next one is autonomous vehicles. In vehicles also we are using, I already told, between the vehicles and infrastructure we can provide traffic management. Smart architecture we are using. We are using smart architecture. That means IoT for a soil crop. We already having the sensors for crop. That means to monitor the irrigation purpose. And in our stage also they are asked question. Many of the students are studying in agriculture field, but they are not going for a farmer side. But they can use this and they can go for farmer side and they can develop their economy. Then we Then edge computing with 5G, it can be connected with more than one system and it has a several access and can for example, if one person is using data sharing, they won't get any download process will be slow. But using the 5G, that problem can be avoided. The one of the main thing we have to focus means we have to focus on the security. Nowadays, the cyber security issues are raster thing in day-to-day life. To avoid that, we have to make these kind of things with security. So it is a robust one. We have to provide these kind of things. We need to maintain our security and everything very hard. Then only we can avoid some of the vulnerabilities. And the cyber security consequence, I already told, we can also use blockchain. You all know the supply chain. For that concept also we can use. The main thing we have to focus on the security only. We have to provide infrastructure cost is high in 5G generation. So that is one of the main problem. And we have to the researchers also can use these kind of things and their findings. So these are the applications we can have daily queries. Any questions?
So I should get the novelty of your research work.
Sir, just we are telling that 5G is better than 4G. But they are nowadays they are working on that. We have get this information from information communication technology. Based on that only we have. So still it is the working is going by many researchers. We are so it is a trending topic. So we have explained. We are just given the application. We are just given the application.
We have in standalone technologies. I don't think in India you don't have a standalone technology. Still you are in.
No, I'm telling that only. We are going to improve that one. I'm telling. I didn't tell that we had developed it. We are going to develop it.
How are you going to do that?
We are going to improve by maintaining the security process. We have to build the infrastructure. I am giving the idea. Technology.
So do you have 5G in India?
Yes, we have it 5G. We are using 5G, but there is a technical issues on that. So we have to develop some network changes.
Because in India, the biggest issue is the coverage.
Yes.
Because of 5G, these are very high frequencies, they cannot penetrate for long distances. So we should improve the infrastructure.
That one I am saying.
Yeah, my suggestion is you can go and develop that. Develop non-standalone 5G for India. That's the best solution at the moment. Because you already upgrade the infrastructure. You can use the same 4G core network. Using the 4G network, you can give the service aggregation using 5G. That's where we started in Sri Lanka. Now we are developing that to 5G advanced. Okay, so maybe you focus on that area and then see what are the services you can provide to the non-standard 5G like telesurgeries and because we don't know about latency now. Because even though you are saying theoretical is having less than 1 millisecond latency, you will feel the latency is very bad. So focus on that. I think that
Yes, in future we will see that. Thank you for
Present 4G, without 4G, 5G is not possible. But 5G is not like that.
you don't have 80 advanced, right?
5G
No,
network.
we have 80 advanced in India. No, right?
With the help of, because security is problem and also they are using weak
So they are working on that. Many researchers are working on it.
Also one major problem is also there.
Because we are population is high, sir. So we have to focus on that. We have to focus on certain constraints. So we are just moving to that.
Suppose we are
Here people are less. You can connect and everything less. But India, that means our country, the population is high. That is also the one of the aspects that we have to develop in certain areas. That is also one of
wanted to do different massive mine or mine, that kind of answer, take that to India.
Okay, sir. In the future, I will. Thank you for your.
Thank you for giving this opportunity.
Maybe understand now.
Any other questions from the audience? Okay, presentation. We have one question. What are the key performance metrics to consider to evaluate the influence of 5G on data science? Key performance metrics. We evaluate the 5G.
So in which specific concept also we added for this. For these centralized analytics concept. So these everything we depend nowadays everything we depend on the cloud company, cloud infrastructure. It's a little of edge computing concept. We never depend on the cloud infrastructure. We have to decentralize all the analytics portion.
Thank you.
Revolutionizing complex medical procedures.
Recording in progress.
And here to present the topic on AI and the words are based on the especially learning and habit feedback. Habit feedback is mainly to another surgeon to do this enter the specific that the surgeon should not be caution towards the surgeon who will not enter because the patients will need then when you go to stable finally augmented reality. Augmented reality is like something in the reading technology is very more in this AI system surgery is mainly first thing is like cost. And secondly, the future mind process can be done by AI driven robotics. For example, when you are doing tendencies, by using augmented reality system, we are physical outcomes and do surgery more precisely. By using AI, surgeries is more safer. Like, one of the things where it's supposed to be done like that. How AI and whatever the surgery you are doing or you are involved, that only you have taken this data. One of the surgeries like chemotherapy and not from others surgery. Even for others also. Yeah, surgeries. Like surgery, and finding the tumors.
How do you explain it?
That was before. Like knee bending. Like in that case they are using it. But the current surgery is like knee replacements and like neuro surgeries like stabilized removal and tumor removal.
So after this review, what is your conclusion? What is your aim?
To improvise the procedure and to improvise the aim.
Can you specifically mention what is your goal?
My goal is to reduce there is a thing known as bone tumor, like bone cancer. In that area, the people will be removing the bone and like bone cord, but the bone cord of the bone will not. So we just need to preserve that. Like 23 years old this woman not lost their
The problem is that he is asking is when you are doing research, you have to narrow down your focus. So then you can say, I have developed a AI image processing to see where cancer is. Like that, you have to say a specific area. What is your interest? What is your area? We can go just general.
It's not a general thing. It's actually opposite and universal. It's not a general thing like a general
So there are AI assistant surgeons, totally different AI, and totally assist the surgeon that with the KY, I think the right term, the meaning is KY.
No, so AI is a guiding thing. The lead is the correct for the
Yeah. So those is the assisted.
Yeah.
So like that we have started
Like example, tumors might not be removed 100%. They remove like it may be removed like 80% or 70%. Like the surgeon tries to remove or discuss it's the patient's like to remove. It may opt to be like to let us also patient outcome.
Thank you. Now I please to invite my Shankar via the paper. IoT-based smart farming featuring automated feeding and automated lighting.
Good evening to all. My presentation on today is about IoT-based smart farm, featuring automated feeding and lighting. This project focuses on improving livestock farming through automation by using IoT components like sensors, relays, and an ESP32 microcontroller. The system reduces manual work, saves time, and enhances animal welfare. The system was successfully tested in a simulated farm environment and showed promising results. And these were the basic contents of my presentation. Now let us move on to the introduction part. In Sri Lanka and many developing countries, livestock farms still depend heavily on manual labor. This leads to inefficiency and inconsistent animal care. My IoT-based solution combines hardware and software to automate feeding and lighting tasks. It allows farmers to control and monitor everything through a mobile app using real-time data. This project supports modern, smart, and sustainable agriculture. The system is designed to be flexible and adaptable for different types of livestock, such as cattle, poultry, goats, and pigs. It can be scaled to fit both small backyard farms and medium-sized commercial operations. The design focuses on affordability and simplicity to ensure accessibility for rural farmers. The problem statement is the traditional livestock farming faces multiple issues such as irregular feeding times affecting animal growth, poor light management impacting animal comfort and productivity, over-reliance on manual labor which is time-consuming and costly. Existing automated systems are expensive and not suited for small farms. Therefore, the cost-effective and reliable smart solution is necessary to assist farmers in their daily operations. So the research objective are the study focused on 5 key objectives such as automated feeding using proximity sensors, control lighting automatically using photoresistors, reduce the need for manual labor, provide a simple and interactive mobile interface for farmers, lower operation cost by minimizing feed and energy waste. These objectives help make farming both efficient and sustainable. The scope of the project adjust brightness according to the surroundings light intensity. These areas are chosen because they are the greatest impact on animal health, productivity, and labor efficiency. The technology used and the hardware include proximity sensors to detect animal movement near feeding areas, relays to activate motors that dispense feed, an ESP32 microcontroller programmed in C++ to process sensor data and control operations. Together, these components form the physical backbone of the system and operate automatically without human input. The software side integrates IoT and cloud technologies. Firebase is a real-time database, stores live data and synchronizes it across devices. C++ is used to program the ESP32 microcontroller. AWS IoT with MQTT protocol ensures reliable communication between devices and the cloud. Visual Studio Code and Figma were used for system and interface development. This combination allows continuous monitoring and seamless data transfer. Next, the system architecture. The system is built on three-tier architecture. One is the presentation layer, which the mobile app developed with React Native, allowing farmers to monitor and control field and lighting. Second is the application layer, which is the AWS IoT process sensor data, executes commands and manages communication using MQTT. Third is the data layer, where Firebase handles real-time data storage and synchronization. This design ensures flexibility, scalability, and security in system communication. Before development, a questionnaire was used to collect data from the farmers. It revealed that feeding and lighting were the most time-consuming manual tasks. Many farmers also lacked affordable technological support. These insights guided the development priorities, keeping the system design cost-effective and suitable for rural conditions. The prototype was built using ESP32 and tested with proximity and light sensors. Data was transmitted to Firebase in real time. Feeding automatically started when livestock were detected and lighting adjusted according to the daylight levels. The system reduced manual work and maintained consistent feeding schedules, leading to better animal welfare. Overall, it achieved a 28% reduction in manual labor and 15% of improvement in feed consistency. The interface was designed using Figma and implemented in React Native for mobile use. It allows farmers to view live data, feeding history and control settings remotely. The interface is simply responsive and supports both web and mobile platforms, enabling easy access even on basic smartphones. The study was supported by previous works on IoT in livestock management and smart agriculture, research on automation, feeding systems, and energy efficient lighting, provided valuable design insights and helped validate the approach. To conclude, the IoT-based smart farming system effectively automated feeding and lighting. It significantly reduced labor time and improved animal care consistency. It shows that IoT technology can transform livestock farming and more sustainable, data-driven practices. Thank you for your attention. I am happy to answer the questions. Thank you.
be measured 28%. If you apply the measure that 28% is actually manual labor and 15% improvement is feeding consistency. So what the criteria were used to determine those ranges?
Yes, sir. We didn't include the system and tested the labor hours, and then we included the system and tested. So that's how we found the manual labor hours.
But as per your methodology, it seems like it's a prototype. So how did you compare the results with the real farmers?
No, sir. Our original Prashant has implemented the project for small scale farm, yes. Okay, sir.
Actually, it's not a development, it's a research.
Yes.
Okay, thank you.
Thank you, sir. Thank you.
Thank you. We will now proceed to the certificate awarding to recognize and appreciate the contributors. I kindly call our co-chair and chair to present the certificate for the awarding. Dr. R. Kalimani.
accuracy, for fast interface, for latency, how occasional for processing latency display, is application accuracy, it's poor condition, conclusion of my presentation. In conclusion, in this system demonstrates that real-time communication it can easily
Thank you.
large areas can do generalization of environment, integration, alarm system, auto enforcement protocol is also possible. So this is my real life website. So thank you. What's the field?
So you have another research, real-time database detection of referencing CCTV footage.
Yes, sir.
My question is, why was the Dodo V8 nanomodel specifically chosen for this application?
So it's a performance and most accuracy. So I use that with vision and accuracy.
Okay, you have used 7,400 images, right?
Sorry?
You have used 7,400 images.
Yeah, I use it.
Three different classes, right? How many images you have used for training? Training, validation, testing. How many images you have used?
After getting 7,400, most images are valid.
You have in your data set there are 7,400 images, right? For the augmented images, so after training you have done the augmentation only for training images. So before splitting the data, you did the augmentation. Where did you do the augmentation?
So I can't clearly voice. Understand.
You have you mentioned that data augmentation, no?
To discuss a project that's very relevant in digital, in today's digital world, phishing identification and misinformation development. I'm here with Sarah Johannes to present this further presentation. Let's move to the introduction part. This project focuses on developing a machine learning-based system designed to detect phishing emails in real time. So we all know that phishing emails are a significant threat to personal individuals and organizations. To machine learning for the filter and more accurate detection. Let's move to background. What's in background to this project. And mission and attacks have become more sophisticated and making it difficult for traditional methods to be. So in this project, I explored the need for a system that adapts to new phishing techniques in the real time, ensuring more efficiency in security. New phishing and here, to build this system, to build this phishing techniques, and to build this system, for the front end, I employed the HTML and CSS for the user interface and the backend for the backend processing. I used Python and NetBeans classic for the server-side processing. For the core machine learning knowledge, I utilized libraries like scikit-learn, XGBoost, LibraryTM, and values, which are known for the high performance and versatility in classification tasks. And the methodology behind the system involves 4 steps. Like first, the most important part for the every project is the data so, for the data collection, I get a large data set for fishing and the second one is the structure. For this, I focus on multiple elements like keywords and water and data distinguish, fishing and eligibility. The third one is monitoring, and I compare several models including base, KNN, and the XGBoost to see which matches the best. And for the last one is the model evaluation. I tried 5 models in India, Navies, KNN, XGBoost, and Live. For that, I used and finally, by comparing these these old models are actually 100% accurate. However, was selected for the requirement of its speed, efficiency, and the future importance. And here I attached the training time, prediction time, the most speediest one. And here I identify the trend to observe the output system. So for the execute, the prediction time is less than the other folks. And finally, for the here. Look at the confusion matrix for the extreme here. As you can see, there are no specifications and it's a perfect outcome. This matrix evaluates the model's performance and its activity necessary for efficient events. Finally, all the confusion fishing events. By selecting XGBoost for production, we have ensured a system that is fast, scalable, and feasible. The real-world impact of this project extends beyond just protecting events. It also serves as an educational tool in the future to raise awareness about the competition. And thank you for your attention.
Fishing email detection using machine learning, right?
Yes.
That's the binary classification, no? Python for fishing and Python for detection.
Yes. Yes.
Where do you get this data, sir?
Sir?
Where do you get this data, sir?
For the data sets for the experiment emails, I get from the emails where I get and surroundings, and for the fishing, I get from the websites.
The HD boost, the prediction time was less. If the time is 0.003 seconds for the prediction, that's why I left. I couldn't type anything.
How many images you have tested?
Those in text.
Sorry? How many?
Those in text. 10,000 emails.
You collected 10,000 images. How many images you have tested?
All the 10,000 email texts are tested.
How many you are using?
The
How many you have used for your data set?
I didn't train the images, I trained the text only. I didn't train the
What are the confusion matrix? You have seen in the slides the confusion matrix. There are 10,000 images are tested. But you mentioned using 10,000 not tested.
No, text, the 2007 and the predict is using 2003 something.
Because all the information 100% using. Okay, thank you.
Thank you. Now I can call Nishan to present the paper Genetic Algorithm-Based Intelligent System to Automated Use Trees and Algorithm.
introduce the flow manner, switching efficiency, First, the lack of faculty is specific minimal weight and feedback from visualization of CAs. Weak interaction with institutional database. Need for scalable imaging system to complete for administrative environment. So, I believe project address the identity gap by developing a web-based intelligent exhibition system or web journey. It's often McCarthy specific configuration and mission organization and individuals. This database is used for efficient and conflict-free error generation. Which includes student enrollment records for students, lecture years and future, many capacities, and next system data processing, backend and use functions and response from the clear and use and geo-optimized is generally available. So I use communication for random design and fitness evaluation, which is used in scheduling, for the testing purpose, I give my screenshot. First, I analyze the counts and speak out with first. Next, where the force. Next, always generate sequences. I go to generate exam available designs. Distribution it is about the business knowledge and reinforce simple platforms keep upload outputs. Hence, meaningful large data set efficiency is helpful significantly reduce manual effort compared to methods. Conclusion: this isn't work and exam time. Schedule for academic it's so many variations and manual effort using data. This is the this is Yes.
We have researched genetic algorithm based intelligence systems for autonomous exam time frame data.
Yes.
We apply the system recovery.
Yes. Yes.
Question is how does the genetic algorithm, so genetic algorithm performance compared to other optimization?
Sorry, sir.
How does the genetic algorithm compare to other
Sorry, sir. Sorry, sir.
Is better, flexible, and balanced between performance and coherence. It's give fitness score and select the best one and give performance and coherence. Give fitness score, give fitness score and select the best one.
you need to display that interaction statements, right? In other optimization. Then you can say governance any of the can you elaborate on the time complexity of the algorithm? When scale
So, I decided for the simulation is 3 semesters. Without 3 semester in simulation like and in 3 weeks. Our time. Thanks. Thanks. Thanks.
And Asha Parsis. Good morning, respected members and fellow researchers. And Asha Parsis from Department of Computer Science, Chindamani Campus, Eastern University of Australia. Today, I am pleased to present the result on fabric This research focuses on improving textile quality control through intelligent vision systems and approach that combines visual and automation to make inspection faster, more reliable, and more consistent. Let's walk through the slides. In textile industries, fabric quality, durability affects the market value and reputation of many textile involving manual inspection methods still dominate in many factories. These methods are time-consuming, subjective, and often inaccurate depending on the experience of human bodies. As a result, small defects such as stains, oil, or thread errors often go unnoticed during production, leading to process by learning visual pattern that differentiate effective fabrics from the process. This research revealed the resonant 18 ppm a powerful computational method to detect and classify common fabric defects of the precision and repeatability in manual inspections. Existing machine-based systems often focus on detecting only one or two defect types and fail to adapt to real-world variations in fabric texture or lining conditions. Therefore, the goal of this research was to develop a robust and generalizable model that can detect efficiently the results such as resonant aging, improved detection accuracy, and reliability in textile quality control systems. Our work aims to answer this question by combining machine learning techniques with a user-friendly interface for real-world industrial applications. Several studies have been conducted in fabric defect detection using both traditional and modern approaches. Traditional images processing techniques such as thresholding, edge detection, and morphological filters have been used to identify irregular patterns. However, these techniques often fail when fabric texture or ambiguity. Research directly from data. However, many of these studies lack real-time integrations of interactive interfaces for practical industrial use. My work attempts to bridge this gap by developing a deep learning model integrated with graphical user interface that provides immediate results and suggestions. The BGG model, for example, has been widely used for fabric classification, although it achieves good accuracy, it suffers from extended training time and requires high computation resources. In contrast, suffers from extended training time and requires high computation resources. In contrast, reuse features learned from large datasets like ImageNet. This significantly reduces training time and improves accuracy even with smaller fabric datasets. Additionally, our implementation includes a Java-based graphical interface, making it much easier for users to operate without technical knowledge. The dataset used in this project includes four main categories of fabric images: whole, stain, threadbare, and good samples. Each class contains multiple images representing different textures and lighting conditions. To enhance the dataset, data augmentation techniques such as flipping, rotation, before changing, all images were resized to consistent dimension and pre-processing step was essential for stabilizing and improving model training. The core of this system is a Resonant 18 architecture which introduced residual learning to overcome the vanishing gradient problem. This design allowed the network to be deep while still learning effectively. Using transfer learning, we started with pre-trained weights from ImageNet and fine-tuned them on our customer fabric dataset. The add-on optimizer was employed to enhance conversion to recognize subtle difference between each defect's category, improving its accuracy over time. The proposed model achieved a validation accuracy of 77%, demonstrating reliable classification across the four defect types. good, hot, stain, and threadbare. The confusion matrix confirm strong accuracy for most classes with minimal misclassification between similar textures. Importantly, the project also includes a Tinder-based graphical user interface application, allowing users to upload a fabric image and instantly receive a prediction with the treat with an appropriate strain removal like this. This makes the system both practically useful and cost effective for textile manufacture, significantly reducing manual labor and inspection time. While the current model performs well, there is still room for improvement. Future work includes extending the system to real-time camera-based defect detection, so it can monitor fabric during production. Another direction is defect measurement, where the system calculates defect size and location for quality grading. Expanding the dataset with more defect varieties will further improve model robustness and accuracy. Ultimately, integrating this system in summary, this research demonstrates how machine learning, specifically resonant aging with transfer learning, can automate the detection of fabric defects effectively. The system provides reliable accuracy in interactive defect correction suggestions and a user-friendly interface for real-world use. By automating the defect inspection process, we can help textile industries save time, reduce error, and maintain consistent quality standards. This project shows the potential of combining AI with practical engineering to enhance productivity and precision in manufacturing. Thank you very much.
What's the title?
Sorry, sir.
What's your title in research?
Fabric defect detection using machine.
Proceedings. Deep learning based web application for automated fabric defect detection in the textile industry. Fabric defect detection in the textile industry, right? In this, okay. Could you please explain your data set?
Again, 600 plus data.
600 plus, say actual number, how many images?
Sorry, sir.
How many images you have used?
Each classes I use 200 plus images. Also, I use data augmentation like flipping notification.
Wait. Each class you have used 200 images. Altogether there are 4 classes now.
Yes, sir.
Altogether 800 images.
Yes.
So good 200.
Good, I started with
600. Right? Okay, how many images you have used for training purpose?
70%. 70% for training and other for validations.
That is 34 validation, right? Out of 30%, sorry, validation 30%, right? So your accuracy is 77%.
Yes.
Why didn't you apply Session 50 or efficient data or there are advanced one techniques there? Advanced. So why you are not using the advanced answering techniques?
Because it's need more data sets and more training tools. Result 18 is the lighter version. So I use result 18.
So where you use the data augmentation, before splitting the data or after splitting the data you can apply for data augmentation.
Before splitting the data. Because for the diversity.
Actually that's wrong. If you want to split the otherwise it may be minus. So already the same copy of images come to testing part, right? And training part. So your performance will increase. So that's bias part. So we need to avoid overfitting, right? So do you have any ideas to avoid overfitting?
Sorry sir, I didn't understand.
Do you know overfitting?
Overfitting. That's why I include data augmentation. It is increase time speed, reduce overfitting.
If you use the J-form personalization, then you can avoid this optimal overfitting.
Thank you.
Natural language processing powered multilingual chatbot for student and development assistance.
Department of Computer Science, Agricultural Science. My research is natural language processing power analytical control for student development systems. This sequence introduces natural language processing power analytical control that support student development systems. The primary goal is to help students especially for those who speak similar language or English. The chatbot addresses the repetitive workload faced by campus administrative staff and automating responses to frequently asked questions. By doing so, it improves the overall student experience and provides real-time support in unknown languages. Now let us discuss some related features that inspired this research. Several studies have explored chatbot systems for music and research and even purposes. For example, NEU chatbot developed for natural learning university deep learning to answer admission-related questions. Another study, higher education enrollment for chatbot applied and for admission in higher education support. Finally, educators are having AI-based system provide general related information. These studies highlight the growing importance of AI platforms in education, but none of them offer multilingual support tailored for singular English, which is the main focus of my research. The method explains the step-by-step process used to design, develop, implement the multi-dimensional system. The first step is data collection. In this stage, a dataset of frequently asked questions from new campus credential services. Each question was labeled with its corresponding index, such as fees, inquiry, registration process, or sports facilities. The second step is data analysis. To make the dataset more diverse and realistic, zero-based placement using word that was applied. This means similar words were substituted automatically, allowing the chatbot to recognize multiple ways, asking the same question. For example, examination fees and examination statements are treated as the same image. Third step is data reprocessing. Here, raw text data was cleaned and prepared for model training. This includes normalization, which is text in words, stop which convert words to their base form. These steps ensure that only meaningful information is used to training. The fourth step is model training. A neural network model was trained using three layers: input, in, and out layers. The model learns to classify user relations in correct intent by recognizing patterns in the text. This process helps the platform understand user queries more accurately. The fifth step is test and evaluation. Once trained, the model was tested using real student queries and evaluated through test cases. The next step is testing and evaluation. Once trained, the model was tested using real student queries and evaluated through test cases. Postman was and finally, the system integration stage connects everything together. The chatbot was integrated into a translation for deployment, and Google Translate API was used to support multilingual communication in Sinhala, Tamil, and English. In terms of model performance, the chatbot achieved a 95% accuracy in classifying user intents. It successfully supports English, Sinhala, and Tamil, achieving the goal of multilingual access speed. The findings show that the model performs very well in understanding user interests and providing accurate responses. However, it still has limitations when dealing with complex queries or and expand training days with audience work, student questions to make chatbot even more robust. To conclude, this project demonstrates that natural language processing-based chatbots can significantly improve student support services, reduce administrative workload, and provide inclusive multilingual assistance for a diverse student population. Thank you all of you.
enrollment assistant, right? You have developed model, right? So that you have three languages, English, Kannada, and Tamil. When it comes to the research part, so what the reason the Tamil language lesser performance than others? You 90%.
I can't hear.
Okay, so what the reason for lesser performance in Tamil language, 90%, when we compare with English or Sinhala language?
Yes, sir. I have related.
How many words we have used? And also the problem is the data augmentation. That should be only for training events, right? And other than that, you mentioned that 30% reductions, right? So how did you calculate 30%? Any equations to calculate reduction? From here.
I can't hear you clearly.
Okay.
Okay.
Conclude this session, I would like to express my heartfelt thanks to everyone who made it a success. I sincerely thank our guest speaker, Captain S. Vishwanathan sir, for sharing his invaluable insights and inspiring work. And also a special thanks to our session chair, Mr. S. Obiswaran sir, and session co-chair, Mr. S. Archana sir, for their guidance, support, and expert evaluation throughout the session. Now, I'd also